My little bubble.
So everyone is no. 2 people are not seen.
At least you can see yellow.
No, 3 are not seen.
Oh, yeah.
1, 2, 3. You're hiding well. Probably we can turn the whole station so that it will cover the class.
But then screen-wise, you could get a lot of glare in Zach's area because of the angle.
Of course, you'll find arguments in support of your convenience. So we will be kicked out of here by 7 or even 10 minutes before, so we don't have much time. And when
Oh, Jack.
so if you do have specific questions related to your presentations, raise hand, stop me, and rush to get answers. If you do not have immediate questions of high urgency, I will go at slow pace to whatever is pleasant for me, but your questions are priority. What are we doing? So we all agreed to do presentations where you share practical skills of using software as a tool to communicate the skills to each other and mastering them. And we have covered some of them, and some of them need a little bit of complement. So our time from whatever 5:10 to 6:50 can be partitioned between going through the list or yes, going through the list. And as soon as we finish the list and everyone will be happy about, I can slowly introduce a new piece of software that we will be doing after. I don't know if it is a very good idea because you need to concentrate on your presentations, but the semester is so short that I may need to start something. At the end of our meeting, I will switch the gear and start speaking about completely different software, completely different subject, just as an introduction so that you get prepared to our next meeting, and then we will go quicker. So list of available electronic structure methods. I hope Brendan will be able to go through it, but just in case. One is expected to be able briefly tell what Levi was informally telling to Sam, going through the everything that can replace Hartree-Fock, like mechanical, semi-empirical, DFT, and what they mean to your understanding by today, and declare that the further down to the list you go, the higher is the precision and smaller are the models that you can compute in a reasonable time. It's basically a summary of the first question. Faisal, what you plan to do is a very useful and helpful thing that will educate all of us. By now, he is ahead of probably everyone in the audience about this subject, but do not forget to cover the screenshot of possible choices of the basis set that are available in this Gauss View software.
So that is screenshot.
Yes, yes. And cover a little bit more of practical side. like what are your expectations, or if you have time, which I doubt, maybe take some simple job and compute it with different base sets and see what is the difference. Or maybe without computing, just tell by your own words, whatever is available. So, list of tasks available. Tell a little bit more what each of them are, and we have made only first two, but what are the rest? Which kind of data do they provide? And feel free to either practice something yourself or to go to Gaussian website. We can survive with only the first two of them, but the rest of them are also important. Like scan is for scanning different points on the reaction coordinate. The frequency is normal mode analysis, which is needed for infrared spectroscopy, and the output file will contain frequencies that pop up on the infrared experiment. Okay, Jabet, who is absent. So we have covered in the class the first two lines of his task, right? So we know that we can prepare an input file either by converting the file with coordinates into Gaussian input format, or directly reading it in Gaussian. And then we do have two ways. First, to process the input file with the Gauss View software and click on the right buttons or wrong buttons, and then click submit. Or we can completely edit the input file in the command line. And then in the command line, the header of the file contains most important thing. So if we look here, you can see that there is about half dozen lines with some codes that first to show the parallelization over different processors to speed up. And if you go in the supercomputers of the national facilities, you can use like thousands of processors and do substantially quicker. Then amount of memory allocated, and then the intermediate file which is needed for saving, restarting job further if jobs are very long and angry system administrator stops the job, or there is a power outage, or you just want to tailor your efforts. You may save intermediate values and then restart from there. And also it is a file that contains some auxiliary information. And then there is the list of tasks that you request from the software, which we typically were doing by clicking method, basis set, type of calculation. And previously we were trying like force field, optimize, or Hartree Fock, and value to DZ. It is what we do. And this relief, it goes to the density functional theory, specifying specific functional. We person who will present on different methods. Who is this? Sam? Not Sam. Brendan?
Structure. Yeah.
Yes, yeah, number one. If you select so-called DFT method, then there will be an option to select different functionals. And here, instead of telling DFT, you just tell type of functional. And then one can tell self-consistent optimization or infrared or whatever one needs. And then there is one important line that we didn't cover completely. And I am absolutely sure that Zach and Seth critically need for their research. So the numbers here are typically, if you look in the files that you were doing in your homeworks, were always 0 and 1.
Okay.
Right? But if you do with transition metal complexes, often your ground state is not a singlet. And sometimes, if you do chemistry, you deal with non-neutral species. So the first number tells deviation from neutrality. Is it neutral, anion, or cation? And second number tells about spin multiplicity, which is 1 for singlet, 2 for doublet, 3 for triplet, and so forth. So if your model is an open shell, if it is a radical or transition metal complex, it can be like, I do not speak too much this language, like quartet, right? So, and if you do it with Gauss view, it will offer you most reasonable numbers here, but sometimes you need to go a little away from these prompts and modify it. The letter U here stands for unrestricted, which means that number of electrons with spin projections up and down can be different. And this very little knowledge on how to tailor the input files is helpful if you create a geometry, but then you start to investigate different configurations. Make sense? Oh, I'm speaking instead of Javid. So we were doing number first and line 1 and 2, and what are spin and multiplicity? Well, spin multiplicity and is not needed here. So this is charge and multiplicity. Those are two integer numbers which are critically needed. Okay, and then we do run Gaussian, or if we there are different clusters with different queuing systems, and sometimes this command to submit the job to a calculation is a little different, but it is 5 seconds to learn it from whoever uses this machine, like queue sub and submit. They change from machine to machine, but there are several standards. So on the machine where we work in, it is just run Gaussian with number of processors and input form. So next question is by Tion, how to analyze output file. And if you are bored to listen to me and want to do something practical, please navigate to this directory, borrow the input file.com, transfer it to your directory and run it. Or if you are super bored and you don't have enough energy, you can copy output file too. We are not challenging the cluster for calculations. We are learning the formats right now. So if I'm telling something not very exciting, just copy and run, and we will look a little bit on this model, which is 3 plus titanium. Remember before, titanium is the simplest, one of the simplest transition metals. You can do it once again. Were you given a sign that I'm wrong and titanium should be 4 plus?
No, he was
Oh.
just.
Okay, I interpreted that you tell me it should be 4 plus, not 3 plus. No. So in whatever we were doing before, we took titanium models because it is one of the simplest transition metals, just next to what is before? Vanadium was titanium is second among transition metals, right?
It is the second transition.
And first one, vanadium. Vanadium is a little crazy in chemistry.
Oh, wait, no.
I've heard that it may appear like at any rainbow colors depending on different oxidation states, right?
I lied. It's scandium. Vanadium's 3.
Okay, 3. Good. Yeah. Scandium. But titanium is more earth abundant than those. And so we were dealing with 4 plus
We were.
before in computation. But sometimes it may appear in 3 plus. If you want to stabilize it in 3 plus, we can add 3 anions. And because it likes to be octahedrally coordinated, we can add a couple of waters. So this complex, I don't know how practical it is. It is just a toy for little exercise. Probably in real life, chlorines will go away and it will be coordinated to waters only. But this is a small model. So it is neutral. Total charge is 0. 3 plus 3 times minus equals 0. But if we remove an electron from titanium, then it will be, before we had highest occupied orbital filled with 2 electrons, and now we remove one, and we get an open shell model that needs a specific treatment. The treatment that needs letter U in front of your method, like UHF for unrestricted Hartree-Fock, or UB3 WIP, or whatever you do, for uneven, uneven open shell, odd number of electrons. And here is, before, when we were scrolling through the output file, we scroll as our patience allow, and then we find the record alpha occupied and alpha virtual, right? And then Tion, right? And then whoever presents this method will tell that here is the highest occupied, here is the lowest unoccupied, and the energy offset between them is the gap for the material, for the molecule. Good. But here it's not the end of the story. Look here what you observe. Look at the file. Alpha occupied, alpha virtual. Go further. Ding 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 ding. So beta occupied, beta virtual. So the electrons with different projections of spin, up and down, alpha and beta, form different electronic structures. they may have different number for HOMO and LUMO, and they may have very different gaps. So it is what you need if you deal with transition metal complexes. And then one needs to report two gaps. One gap for alpha, another gap for beta. And you know where to look at. Yes?
No, that's why I cannot get the one that I did. One of the chapters.
Mm-hmm. So one needs to put, if one changes the input file manually, one needs to add letter U in front of the method, like UHF, unrestricted Hartree-Fock. And then this will come up automatically. Extracting without Gauss view, total energy. Total energy, it is a trick from Jabet. Just do grep for SCF. Grep SCF. And for ionization and affinity, according to Koopman's theorem, you just look for energies of HOMO and LUMO. What do you do if there are alpha and beta? You probably take highest of HOMOs and lowest of LUMOs. Right? And just to be confident and sure, you report the second one in brackets. Okay, so grep SCF and the energies for this alpha and beta orbitals are given in atomic units, which are out of zone of comfort zone for many people. So it is good practice to convert them into, say, electron volts by multiplying by 27, or different conversion factors for other popular units. So grep SCF and then name of the output file gives the total energy. Right? So we are done with this subject. Symmetry groups. So we'll skip symmetry groups and give Zach an opportunity to surprise us tomorrow.
I did have one question,
Okay.
which has to do with the tolerance.
The larger the tolerance, the quicker is calculation.
But what does the value mean? Because I found if I increase my tolerance, the number of allowed higher order symmetry groups goes up.
Yes, intuitively, non-rigorous, it's delta between deviations of angles. Like if you go from one configuration to other by rotations, you can allow plus minus like 1 degree or plus minus 10 degrees. And if you allow too much of the error, then rotations by several angles can bring to the same configuration.
Okay.
Make sense?
Yes.
Good. So we will learn from you tomorrow. Good. But please try to be within 3 minutes. Well, I know it is not possible, but we need, as a group, we need to complete in 1 hour and 20 minutes.
Yeah.
So the screen just will go black.
Is there still a queue list for running jobs right now?
Oh, it's queue probably, but
Is it just
no. About running jobs. Please submit jobs immediately. Do not wait until the list is empty, because other people will not wait. and submit, and they will be in the queue.
Yep, yep.
You can also maybe try show BF.
Okay. Well, I submitted it earlier today. It's not done. I don't know if it's because I exited or something.
No, if you submit it to the queue, it should run until it dies, or it runs out of wall time.
But I sent it again. So. No. No.
See what I did? Here is the trick that will help only to one person in the group, but you can be this one person. If you type Q login, there is a, and then type the password, there is a one or two reserved nodes that are staying away from Q, and if you type Q login, they are at your disposal without any wait.
That is a dirty little secret.
VIP access.
Huh?
It's VIP access.
Yes, VIP access, but we do not have special password. It is VIP access for everyone. So the only disadvantage is that you cannot run 20 jobs in it. It is like, we all should understand that. Maybe some of us need quick turnaround, like 10-second job, and we cannot wait a week until others complete stuff.
Quick question.
Yes.
How do you tell Gaussian that it's not a singlet? So Gaussian says O2 is a singlet, right? O2 is a triplet.
You just modify it in the.
You have to modify it in the file?
Yes. You need to
No.
modify it in the file.
You can. I think you can do it in Gaussian. If you go, you know where the energy is.
Yeah.
The next one over your methods, like the third line down, it can. I think you can say what it is. Do you have Gaussian open?
Yeah.
So if you go to
Method.
methods, spin.
Yep.
Oh, okay.
Change triplets.
Okay.
So here you can change charge and multiplicity by saying whatever you need.
Okay.
And if you change your charge, your options will change.
For not any charge, so not all combinations of charge and spin are allowed. Like, and it is not general. It is specific for your system. Like this system is neutral, but it has odd number of electrons, so for it has missing singlet. If we change its charge, then it should.
Okay.
Yeah, then it will allow singlet and triplet.
That'd be if it's titanium 4+.
Yeah.
Okay. All right.
But I do not need to run anything. I'm exiting from this VIP mode. Bitme. Perl scripts to extract density of states out of log files. So I was suggesting use terribly large, huge fonts, because I was looking on the recordings, and even with good equipment that we have in the recording, it gets like this recording will be like a black line. This will be capital letters will be seen, lowercase will not be seen. They will be like block, nothing. So use like font number 30 so that it will fit maybe 7 lines per the whole screen. And especially for those who will sit on the black back row, you probably will appreciate this. So if it is a couple of more slides, it's okay. And do not spell everything that you want to speak on the screen. You can put the main points and then speak out whatever need to be delivered. If you fear to forget, you can add notes and then go into presenter modes and look on your little cheat sheet.
But I have already put everything.
Huh?
I have already put everything on the slides.
That's good. That's good for your education and record. But we need to give everyone an opportunity to speak, and we need to vacate in short time. So like if you do 6 minutes instead of 3, it's fine. If you do 9 minutes instead of 3, it is fine. But if you do like half an hour, then you will step on the feet of someone else. So the list of energies of orbitals is good when we play with small molecules, when there are few orbitals. But if there are hundreds and thousands, one needs some unified way to treat them. And there are pre-defined scripts that extract energy from the Gaussian output file and convert them into so-called density of states, which the definition is number of orbitals per unit energy, per interval of energy. So what if we have spin unrestricted calculation? Then the scripts are changed a little bit because we have two sets of orbitals, and I am planning to practice it right now really quickly for this model that is predominantly open shell. If you have prepared everything and you are busy, it's not critically needed to add, but I want to cover it at least in the lab. So it is optional for you to speak about it, but I want to cover it because some of us may need it for practical research. So the little manual is included in the prompt file. Those Gauss spin, because we cannot count that our memory serves well every time. And then the script should be run twice. So there are two scripts, one for alpha, another for beta. For those of us who enjoy programming, it's just the two copies of the same script with parsing different keyword, alpha or beta.
Why don't you just make it one script?
You can do it. You have time. And if you share it with the group, it will be appreciated.
I would probably just make a bash script that calls both of those scripts.
Here is optimization. So you run one. Observe that there are additional files, and the parameters here are the same as for the singlet. Number of grid points, the energy offset between grid points, and the how many below HOMO and how many above HUMO. LUMO. So the here is a little legend explanation. What are they? And upon running these two scripts, there will be two sets of files. And the density of states will be automatically generated in the files DOS alpha and DOS beta, but since we want to convert, well, if you like origin or
Excel?
Excel. You just take these files, download them, and plot with your favorite program. But there is an option to convert them into graphical files through GNU Plot. Thank you. And here we do have an borderline overlap between subject by Whitney and subject by Aaron. So if we do have these files, we may want to convert them into unified names. So whatever system you do, whatever directory you are, you rename or copy the long name with all specifications with more generic DOS alpha, DOS beta, and then you run the script that converts this sets of data columns into graphical file. If you are curious what is inside, you see it is nothing but plotting these two files together. And if you look into the files that were created, there is a file with extension PS, which is ancient. So you may want to convert this file to PDF. And then upon we do have this conversion, one may want to bring this file to the local computer. And then you see the visualization of the. Please do not hesitate to follow the steps and do them for yourself. I will not design homeworks or track it, but you may find it useful for your personal research. So before, we used to have density of states that looks only as upper part. And for this transition metal complexes, we expect occupied orbitals with localized on the ligands and unoccupied orbitals localized on the transition metals. So typically, well, sometimes it changes, but those could be d orbitals. But here we remove one of the electrons from occupied ligand orbital, make it unoccupied, therefore there is a change in structure and the image of the density of states becomes unsymmetric. If you do unrestricted calculation for singlet, for the model with even number of electrons, it will look mirror symmetric. Same for alpha and same for beta. But as soon as you go for away from singlet, it starts being different. And who needs it? Those who deal with open shell or radical, and those who deal with magnetic materials. So magnetism is in simple language is a difference in number of alpha and beta electrons. So it will be magnetic materials. Some people make transition metal magnetic doping in quantum dots. Dilute magnetic semiconductors. Example DOS, and now we have a spin density of states. Spin density of states. Any questions? Because this is a little novel. Or objections? Do you think you will be able to do it later if you need it for your research? So it's, you know where to take the instructions in this little prompt file.
That's in the bin, right?
Yes, yes. Molecular orbitals. What are they? Definition.
Linear combination of atomic orbitals.
Yes. The good. And they are introduced in Hartree-Fock theory and then used in some few other theories, but they are intuitively helpful, although it is doubtful question if they can be observed in real life. I just want to be careful and not say something that is not 100% supported by experiment. But they really correlate with observables, and one can use picture of transitions of electron from one orbital to another one as a very good analysis. So when we run Gaussian job, there is a formation of .chk file, which helps to restart and contains intermediate information, as well as information about all orbitals and something else. In order to help reading, one needs to convert the .chk into .fchk, just by format of the code, and it is done by the command form check. Right? As soon as you have it, you apply the give me a second, I want to copy paste the image and put it into PowerPoint as if I would present tomorrow. Print screen, paint, Control C, go to PowerPoint. Insert this image into the presentation. It is so 3 minutes for preparing 3 minutes presentation. Oh, do not listen for me. Spend 3 hours. Okay. Orbitals. If we, let me type top, otherwise it could be too late. Make auto logout. So, if I'm going to Google and type CubeGen, it will surprise me with tons of manual information. So how to convert the form check file into the files that can be plotted. And one can spend days of reading it. But we need very few examples. So by scrolling through, one can see that one can select different molecular orbitals, one can type HOMO to LUMO, and one can do different density of states, but different density of grid points. But what we need here, before we were using MO equal number of orbital that we extract from the .log file. Here is a little addition. AMO and BMO. It is what one needs to do if we deal with spin specific with unrestricted. So since I do not trust my memory, No, I can trust. It is not as complicated. So I'm typing cube gen. Then I type the letter O for orbitals. Then I'm typing before in our previous life or 2 weeks ago in this lab, we were typing MO equals number something. Now, if you have alpha and beta, we type AMO equals, let's say, 31. The HOMO and LUMO for alpha and beta are 31 and 32 for this specific model. And then,
Can you just put homo in there?
Yeah.
yes,
Okay.
but sometimes you need more than HOMO and LUMO are different for alpha and beta, and sometimes for your practical research you may need more than HOMO and LUMO.
You can separate them by commas. So like you can say homo, comma, lumo, and then it generates both in one cube.
Oh, that's so much easier.
But it's hard to visualize in JMO that way. Hey, JMO is
I don't
the
use
bomb.
Try it sometime.
And then you type reasonable file name and call it Q. So same as we did before with just letter A for alpha and letter B for beta. And then we can explore different options to draw them, but one of the quickest, if you do have Gauss U, we can open this BMO and plot it. So if clear, right? Just one letter more. If you do want to get a little more of physical insight, you can draw several orbitals and just merge together into one picture to have it more representative. Otherwise, if you tell figure 1, orbital 1, and then do 50 figures, it is a little boring. And if they have just a little character, then either in one or another one doesn't need to do too much of them.
So on one, the homo is localized to the metal.
Yes,
The other,
yes.
the homo is localized to the
Right.
ligands.
Right.
Okay.
If it will be 4 plus, the HOMO would be on ligands. Since we did a 3 plus, we have this empty orbital, not empty, filled orbital in the titanium. So we fill one titanium orbital with an electron, and it appears inside the gap. Orbitals far from HOMO-LUMO region look more or less like mirror reflection, but those in the middle of the gap are perturbed. How to plot orbitals for open shell configurations. Done. Some people of the old school, well, we do not have so many people of old school here, maybe on the Dr. Morris and Dr. Budjak. But many people were developed at the time when there was a little of quantum chemistry, but there were no tools to render images. And sometimes they argue and they I'm not talking about our colleagues here, but I had it in my experience like 10 years ago at different institution. So that old school people refuse to analyze images of orbitals. They start telling, I don't understand what you're telling. Tell me in a chemical language like bond order, or give me a definition, what are those blobs? So the one electron molecular orbital is defined at each point of space. And these cube files are corresponding to the splitting of all space around the molecule onto very small three-dimensional cells, as we did in our lecture for Thomas Fermi. And then it tells how many percentage of the electron is in this cell, But if we plot every of the cell, we will see nothing, because they will block the vision. And for us right now it looks natural and simple, but if you want to be a little bit more rigorous, we may provide a concept of so-called isosurfaces. It's basically what we do. %90 of people would understand you without this concept and without this unnecessary rigorosity. But formally, suppose we have one-dimensional function. There is x and there is f. Suppose that we are one-dimensional people, which means here is a one-dimensional I of one-dimensional person. And this I can see either yes or no, 1 point. So of all function we can see either it is above some threshold or below some threshold, right? And if this one-dimensional person can look from different sides, this function can be identified only as a size of this function between these critical points. So we can identify at which point x1, x2, at which point our function is equal to ISO value. So we specify an ISO value, and then we get 2 points out of complicated function. Well, maybe more than 2, but much less than infinity. If we select this ISO value a little bigger, then the size of the function will be smaller. If you select this threshold lower, then the size of the function will be bigger. So projecting the same idea for three-dimensional sets of data, we select only those surfaces where our function from molecular orbital, real part of x, y, and z equals a specific ISO value. So then we have projection from three-dimensional cloud to two-dimensional surface. And the orbitals that we are plotting are those ISO surfaces. Most of people will understand it, but if you tell to like advanced mathematician who never saw these orbitals, you may need to add this definition, or you may to impress your reader in the paper by like not just my orbitals but my ISO surfaces. What is next? let's give Levi a chance to surprise us with his presentation tomorrow.
Why?
Because it is, otherwise there will be no intrigue.
Oh, okay. So my presentation is not that bad. Is that what you're saying?
It's good.
Okay.
Let's see, let's make a, if you have doubts on quality of your presentation, we can set up a quiz based on the material you present, and then if the grades are low enough, you will be guilty.
No.
But if one adds together all, or if one takes absolute value square, add all orbitals together, it will be total density. And one can plot it also. Any questions regarding tomorrow's presentations?
Nope.
So I'm just introducing the concept of isosurfaces, and he's gonna go into the in-depth part, right?
You cover as much as you can about orbitals.
Okay.
I'm doing Mulliken, right?
Yes, and Millikan charge distribution. So it is projecting of this total charge density on the vicinity of each ion and telling how much charge is around specific ion. And then one can numerically check that, for example, this titanium is 3 plus, or maybe 3.1 plus, or 2.9 plus.
Yeah. Mulliken, you can't get accurate numbers.
Then you may explain why.
Okay, so in our group talks, we've talked about it a bit, but is it the effective shielding of the nuclei?
It is choice of orbitals and definitions.
Okay.
It's not physical.
So we don't have a complete basis, it won't ever, okay.
So, what are we doing now? Let me ask once again if everyone is happy about presentations. So, the philosophy is the idea of presentations that sooner or later, voluntarily or involuntarily, we will do research. I do not, and you do not care about the course. You care about your big life for research when some of the skills can be needed. And the idea is that if a presenter shares his or her success and failures, it will help others to be more fluent in the research process. So look from your perspective, like how much do you need these orbitals being plotted for analysis of metal organic complexes? What can you learn from them? And is this way of plotting them is sufficient? So you may have different and maybe better angle on the problem than, for example, I do. Do not hesitate to stop me and ask questions related to the presentations. Please submit your PowerPoint slides before the midnight, and it's not my frivolous wish. It is needed for pack them together into one file, print and distribute. Now, if you are worrying about your presentation, you can just focus on it and close your ears with earplugs. But if you're curious about what we will be doing in the course and in the lab in a week from now, I will start slowly introducing new subject. Ready? No one tells ready, but no one also complains that I'm not ready. So I take benefit of the doubt for myself, assuming that everyone is ready. But seriously, I will come over this material once again, so I'm very touched if you sit and listen, but your primary task is tomorrow presentations. If they're not ready, you can take your earplugs and prepare presentations. I do not mind. So, chemistry of chemicals is good, but sometimes one needs to take chemistry of materials, which are not like molecules in the liquid phase. They can be solids, they can be gases, aerogels, they can be different forms of matters. It can be interface between solid surface of catalyst and liquid or gaseous precursor. What is right? Fancy names for techniques. Molecular beam scattering, when one has gas and solid, active solid. So for such, there is a range surface gas, or it could be interface of again solid and liquid with few molecules, or it can be maybe just piece nanostructure of metal particle, semiconductor particle, nano metal, semiconductor, and maybe sometimes dielectric. So if we jump away from small molecules, we may need tools that are more adjusted for a broader range of materials. We may sacrifice a little of precision, which is treated really well in Gaussian, but we may gain broader ability to describe broader range of materials at atomistic level. Do you buy this motivation? So most challenging are solids, because as we have started in a class a week ago, solids are periodic, and if you have repeating pattern of ions, the electrons can freely, or molecular orbitals, if you say electronic state, some distribution in space, can freely move from one unit cell to another with non-zero velocity or non-zero momentum. And this feature of electronic state being moving, having non-zero momentum, is completely absent in pure chemical systems. So it needs a piece of software that takes into account this feature. So it stands for Vienna Initial Simulation Package. So it does have all or most of functionality of Gaussian for chemical systems, but in addition it is designed well to treat solids, interfaces, nanostructures, liquid gases, whatever. So broader range of materials. The benefits were listed, but there, if one goes to this piece of software, one faces immediate challenges. The main challenge, there are two main challenges. First, that as we have seen before, there are so many chemical data formats. So one can imagine that each new piece of software has its own format of saving the data. So new format. Another challenge that stops many bright scientists from using the software is that in Gaussian, as we reviewed today, the input files input file contains all information about computational resources, about method, basis set, about spin and multiplicity, about coordinates, all together. If we go to the new piece of software, then one needs 4 input files instead of 1. So we are starting slowly so that you do not get surprised too much when we get in more further into details. And some people can consider this very awkward and tell, okay, no, if there are 4 input files, will never use this piece of software, whatever benefits it gives. It's 4 times worse than Gaussian. And the names of these names and functional. No, it is not what I planned. Air media. Enter address at the top of the screen. Oh, code 4359. Let's do a quick experiment. Well, maybe not right now, but it should be the way to broadcast wirelessly the image from cell phone to the system. So it's air media technology. And in some of the laptops it is also available.
I don't remember.
Well, this is, oh, it's not on.
So the code is 4359.
It doesn't show up.
Doesn't show up? Okay.
What building is this? EML?
Yes.
Yeah, it's only EML 314 and 326.
Okay, but we can practice it later. So the input files are, I'm lazy to write it again because I was writing it before. So the 4 files here are 1 for coordinates, and the authors of this code are in Europe, in Austria, with native language of German. I don't know how it is connected with language, but they decided that all input and output files should have no extensions, but they should be all uppercase. There are many strange things, but you can forgive them everything for high productivity of this code. So postcar is the file for positions, and I also have no idea what is the connection between car and positions. Postcar is geometry. Then in car, it is not the car that drives in. It is the input. So it is a list of assignments, what we want to be computed, by which method, and like energy, total energy, or optimization, or whatever. The key points is the file that needed to explain to the code about the momentum of this traveling electronic state. So this file needed to explain the opportunity for overall electronic state to travel in space. And if we deal with purely chemical systems but with this code, we will specify that 0 momentum, no travel. So it's not a problem to have a limiting case. And the podcar is for potentials. So since we may decide to deal with elements of all over the periodic table, one needs to specify potentials. So there is a specific approximation that is included into this code that if we are interested in chemistry and optical properties and everything that happens, or maybe ionization, everything that happens in regular life, like lasers, heating, only electrons near the occupied and unoccupied orbitals are involved in chemistry. One doesn't care about core electrons that are like that have energy minus 1000 volts, minus kiloelectron volt. We are not doing. If you are not interested in X-ray detectors, we don't care about core electrons. And if it is a like gold ion, we don't care to excite 1s electron somewhere. Therefore, the core electrons are replaced by an average potential, similar to the potential in Hartree-Fock that is created by these electrons. And this potential is stored for each element included in the model in the file. So it is, if one does heavy elements in Gaussian, one also adds a fragment into .com file specifying this information, that one puts all food into one pot. Here one needs a little different boxes for each type of information. Specific for coordinates, specific for tasks, specific for traveling, and specific for potentials. Make sense? Challenges? Objections? Not yet. If one wants to convert files between different formats, we typically use Babel, right? And maybe recent versions of Babel already make this conversion, but it is a little more reliable to do it by hand with more versatility. So in order to create input file for this software, one should start with .xyz file. So use Babel to create XYZ file of the models that we need. And there is a way to convert what does it mean? We should have about half an hour more. Okay. Not as bad as I feared. So we may convert the files in our previous format, like pdb or .log, into XYZ as a starting point. So I will be taking maybe the simplest possible model. Titanium hydroxide. And looking onto we do have .log file. So I am converting the file into XYZ format, and it is when we were dealing with Gaussian, we didn't care how the input file for coordinates look like. The order of elements was meaning nothing. Yes? Thank you. So I type just Babel input Gaussian 09 log file output XYZ. Let's do different names. Sort. So if you do you see it from the back row what is on the screen or not much?
No, I can see.
No?
Yes. Oh yeah. Yeah. I can see.
Oh, this is the appropriate font for presentations. So you see that it has a little alternating order. Titanium, oxygen, hydrogen, oxygen, hydrogen, oxygen. For Gaussian doesn't care about it. The Austrian program would not agree on such disorder. The order should be everywhere. So how do we restore order? So we do sorting. Sort, one can do it in Excel, but also the command line of Linux does have it. So first number in the XYZ format should be number of ions. 9 is good. 1 titanium, 8 atoms for oxygen and hydrogen. And then it is alphabetical ordered. OOO-TI. And then we do not need the rest. So now we do have our Cartesian file in the XYZ format and it is ordered. Now there is a little homegrown code that would rotate this molecule around each of 3 axes. If we do not have molecular visualization tools, then we still can place like donor and acceptor pairs at each distance and angle. But here it is needed more for the formats. So you type rotate XYZ and then answer 3 times 0 for 0 rotation. And then if we look into we do see that there are some new files appear. And after that, there is one step more. So there is a command that takes this rotated postcard as input and creates the correct input format for VASP code as an output with 3 numbers as the argument. This is intellectual challenge ranked number 4 in the whole course. Many people decline to use the software because of this challenge.
Isn't this your unit cell dimensions?
No, but you are thinking in the right direction.
Okay.
So we run this code, and then we do have TLP so it doesn't stop automatically. So by the nature of this code, it does consider anything that we treat as a periodic system, because it was originally designed for solids. So even if you have an isolated molecule, you can consider its unit cell, it is a repeating unit. And then it takes this poor titanium hydroxide molecule and places it in a tight cage. So like in the store there are cageless chicken. Here is a uncaged chicken. So the cage is made smaller and smaller until it fits it completely. So the smallest possible box that we make without damaging the chicken. Can we do this? Is it possible or it is dangerous?
Depends on what you're modeling.
It is always dangerous. It is not allowed because I do not like molecules. I like chicken. The tail of one chicken will overlap with the beak of another chicken, and they will have too much of interaction energy. Basically, it will be like eating itself from the tail. Or if we speak about molecules, it means that we will create too high density that two atoms will be touching itself on zero distance. So it will be immediate if we will try to compute such a cell, then it will generate huge positive energy. It will explode if we allow it to move freely. So it's something wrong. What should we do? There should be space between each pair of atoms. Even if they are in relations in a chemical bond, there is a bond length. And if there is no bond, there should be big distance. At such big distance where they stop feeling each other, which can be like 1 nanometer. Or if we are non-rigorous, we can say it is half nanometer, but then it is like dangerous, especially while presenting it to people who know who is van der Waals. But we do not have power to free the chicken with vasp software, but we can make the cage bigger. So that there will be larger distance between periodic replicas. Okay? And since it is a three-dimensional chicken or molecule, there should be distance to the next replica in Y and in Z. So there should be 3 numbers that determine the distance offset between the replicas. So the size of the molecule plus this offset will be the size of the cell. So we can put like 6,
We can't see.
7. You cannot? Can you see now? So it was 0, 0, 0 as a CU test, but now we replace it to, let's say, 7, 7, 7, which are distance in angstroms. Then we hit enter, and we look other new files created. Yes, we do see that there has been created file with name postcard, right? And we may look inside.
There's no extension on that.
There shouldn't be.
Yes.
Okay.
I can give you the names and email addresses of the authors of the code. You can write it down later.
I'm okay with this.
Maybe they decided to be unique because all other software developers use extensions.
Or the extension sometimes makes it difficult to email. So if there's no extension, it's just a text file.
Yes. So, how do we read this file?
You get your atoms, you get your cell, you get your number of atoms. That corresponds with that count down. And then these are the positions. The T means if you move them or not.
So T means you move or not?
Yeah, so T means it's movable. I forget what it means. Is it F if it can't move?
Well,
They'll be fixed.
fixed and T translatable.
Okay.
Or you can say thermalized and frozen. So, we can finish the session now, or should I repeat what Levi taught us? Huh?
Repeat. Because I didn't really point, I just said.
Oh, okay. So, which elements are involved in building this model? OT. Okay, hydrogen, oxygen, titanium. Then this is scaling factor which we need if we will later decide to compress or do of the model. Typically we keep it 1. Now the size of the cell. After we took the height and size of the molecule and added this adjustment, it became 11 point something in each of the directions.
And if the off-diagonal elements are non-zero, is it not?
Then we are in troubles.
Huh.
And unless we are dealing with big models of truly periodic solids, we do not need them. So it needs for systems when periodic cells have angles different from 90 degrees. If you do X-ray crystallography, you may see such cells. If you don't, then you're a happy person. And one can represent any periodic crystal in the periodic with a unit cells with 90 degrees, but sometimes changing the angle will reduce the number of atoms in the unit cell. Like the graphene, one layer of graphite with 60 and 30 degrees cell can be represented just by a unit cell with 2 atoms. I can show it later. Just give me- So until the end of the course, we will keep only diagonal elements. Off-diagonal elements are for crazy situations or for crazy people. So, how many of each type are present? H 4 times, O 4 times, titanium 1 time. Some keywords, and then forget about what is written in the row. Just focus on the number of rows. So there are 9 atoms, so you should expect 1, 2, 3, 4, 5, 7, 8, what? 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. So 9 lines. Each line for 1 atom. Or if they are ionized, ion, nuclei, whatever. Center. Everyone is happy until now. Now for each nuclei, we have 6 records. 3 coordinates and 3 keywords. Fixed or translatable, or frozen or thermalized. So this is X, this is a key for X. Right now we put T that geometry can be optimized, or molecular dynamics can be launched. But sometimes you may want to freeze part of your model, which you are confident about, like freeze the surface and allow molecular beam to move. Then you can, for those like freeze titanium, which will be the, so here the order. First 4 ions will be hydrogens. You see there is no letter in front of them, as we usually saw in other formats. So first 4 will be hydrogens, next 4 will be oxygens, last will be titanium. If you want to freeze titanium, you put here F, F, F for the record. Do you like these numbers? Huh? Who likes these numbers? No, no one. What are they?
Extras.
Huh? Look more at the numerical values. Let me increase them a little bit.
What?
Is it in a reciprocal space?
Why so many degrees after the note?
No, they are in direct space. You see? It shows direct.
That's terrible.
Terrible, right?
Unbelievable.
Huh? Any guess what are those numbers? In which units? Atomic units? No, atomic units are just about factor 2 from angstrom. Nanometers? Maybe, but it will be strange. So this is another challenge for the software. So they want to make a universal format, and they have specific units of length for each model.
Oh.
So the unit of length is the size of the periodic box. So it starts from 0 and ends with 1. So one can consider it as percents. So it's like 41% from the bottom of the cage in X direction, 65% from the origin to the Y direction, 40% in Z.
So where is the origin?
The origin is lower right corner.
Lower right, not lower left.
Okay, lower left. It doesn't matter.
Okay.
Yeah,
I suppose it doesn't, yeah.
lower left. Yes, lower left. So how do? So it measures from lower left.
I can pick much.
41% here,
It's lower right.
60.
X, Y. Yeah,
It doesn't
61%
matter. They're
here.
repeating that.
And therefore, if they want to describe it to someone, they call, we use fractional coordinates. Fractional coordinates. But you shouldn't worry much, because we do have a little script that does conversion from normal coordinates to fractional coordinates. And after the computation is complete, there are scripts that convert it back into normal. So you shouldn't worry. It's just you pay again and again for this piece of software being really quick. It's like using manual instead of automatic stick shift transmission.
Those are nice.
It depends. Some people do not share this opinion, but definitely I can make a bet that developers of the software use manual stick shift.
They're in Europe, yeah.
So did I promise no homeworks?
Yep.
Yes.
Ay, ay, ay. Okay, then our next meeting will be more loaded. But your primary task is to prepare presentations and send them within 5 hours to my email if you haven't done so. It will be your hour of glory tomorrow. But if you have too much energy on the weekend and no homework, just an opinion. If you want to invest your time in something interesting, try to convert each of the models that you have into this crazy format. Okay?
Okay.
Good. How do we do it?
But that's not homework, right?
It's not.
It's conditional.
It's conditional is a bad word. It's optional.
It's
Free will opportunity. Where is the camera? Hey, camera! We are finishing the meeting. Web number 6-7 is complete.